Hello students, now we are going to start another topic in this session, and I welcome you back to this session where I am planning to introduce accelerometers and GPS in this session. So this is the one I am planning to complete now, accelerometer and GPS. Accelerometers are sensing transducers that provide an output proportional to acceleration, vibration, and shock. So output is proportional to these three parameters normally, measures all external forces acting upon the moving bodies, including gravity. One important factor concerning accelerometers is that they are sensitive to all external forces acting upon them. So that includes gravity. So that is another drawback here. It is very sensitive to all those factors, forces. Accelerometers use one of a number of different mechanisms to reduce external forces into a computer readable signal. An accelerometer is a single degree of freedom device. It has some type of seismic mass, sometimes called proof mass, a spring-like supporting system, and a frame structure with the damping properties. To obtain inertial acceleration due to motion alone, gravity must be subtracted. So that is gravitational force should be reduced or subtracted or ignored or should be eliminated. So this is the mechanical model of an accelerometer and a free body diagram of mass. It is by principle and spring mass damping. K, this is the displacement mass, and this is the damper, and this is the governing equation. It is a second order differential equation. M d square x by dt square plus b dx by dt plus kx equal to m d square y by dt square. So this is a second order differential equation for this model. So these are all the building blocks in terms of mechanical. We have mass, spring, damper. In terms of thermal, we have capacitance and resistance. It should be here you can see in terms of electrical inductor, capacitor, inductor, resistor, and resistor. So these are the building blocks or analogies between mechanical, thermal, and electrical systems. Types of accelerometers: force, strain, piezoelectric accelerometers, piezoresistive accelerometers, and resonators. For displacement, potentiometric accelerometers, we have seen potentiometers. So similar potentiometers which are used or which are experienced by forces, they will act like accelerometers. Capacitive accelerometers, inductive accelerometers, servo controlled accelerometers, optical accelerometers. So these are the displacement measuring accelerometers. So piezoelectric accelerometers. Piezoelectric accelerometers are self-generating devices characterized by an extended region of flat frequency response range, a large linear amplitude range, and excellent durability. These inherent properties are due to the use of piezoelectric material as the sensing element for the sensor. Piezoelectric materials are characterized by their ability to output a proportional electrical signal to the stress applied to the material. So piezoelectric material, in order to produce EMF, it should be forces should be applied on that. A small mass can be positioned so that it is only supported by the crystal, and as ferrous cause the mass to act upon the crystal. This induces a voltage that can be measured. So that is the from piezoelectric crystal. it is a it is an active type of sensor, piezoelectric material or crystal. Users, if you see, to measure constant or varying frequency acceleration such as automobile braking, elevator ride quality, and even the gravitational pull of the earth. So these can be measured using these accelerometers. Then we have GPS, a global positioning system. So speed and position of a large object, especially of a land or water vehicle, may be very efficiently determined by a geopositioning system. It is GPS. It provides a three-dimensional position estimate in absolute coordinates as well as current time and date as available anywhere on the Earth's surface. GPS operates by receiving radio signals from a number of Earth satellites and by computing the time delay of signals received from one satellite as compared with the other. When When the position of a vehicle is determined with a periodic rate, computation of its velocity is very simple. So standard GPS provides a position estimate in a horizontal plane. So it works on a horizontal plane and flat any locality. So actually land is considered to be the horizontal plane. It was original developed for military applications but has become widely adopted in civilian applications including automobile navigation systems, recreational orienteering, and inventory tracking for transportation logistics. And there are so many applications have evolved with GPS. Nowadays we have GPS system in our mobile itself, so very easily we can track the position of any mobile number nowadays. So many developments took place in GPS system. Space systems. The most widely accepted GPS system is based on the Nav-Star satellite system deployed and maintained by the US, United States. A similar system named Globonaya Navigostania Stupekonia Systema. So this is GLONASS. It is known as GLONASS. It is in Russian word, operated by the Russian government. Another alternative system is being deployed by European Union, named as Galileo. So these are the systems, space systems, which are responsible for measuring the one person or any object coordinates on the earth. Parts of GPS, space satellite vehicles. So we have seen 3 satellite vehicles and control tracking stations. So users applications. Steps in GPS: using satellite ranging, measuring distance from satellite, getting perfect timing, and knowing where a satellite is in space, identifying errors. So this is the steps in GPS, and this is the simple GPS representation. You have GPS satellites. These are all GPS satellites, and you have user, and it is communicated and it is measured by all satellites, and the absolute coordinates of this vehicle is measured by different stations. So these are the stations, monitor stations, and this is known as master station. So this is how GPS is worked or distributed. We will see the GPS working in next slide. So this is the GPS satellite, and it is communicated from the control station and receiver, and data from satellite station and data to satellite station. And here these are the two receiver and control station. So this is how GPS is controlled with a simple diagram. Applications, it is used in many places. Navigation, very important for ocean travel, zero visibility landing for aircraft, collision avoidance, surveying, precision agriculture, delivery vehicles, emergency vehicles, electronic maps, earth science, volcano monitoring, seismic hazards, and tropospheric water vapor. So anything that involves location, motion, or navigation, GPS is required. So for this, these are not listed in the sensors books, and there are other books available for this topic, and this is little advanced topic than the Dioblin and Patranabas textbooks, and the material also I will post in the Google Classroom. You can refer it. Okay, students, thank you. In next session, still we have three more topics to cover. We will complete it in subsequent sessions. Thank you, students. We'll stop here.